Yes. Now we are going to start our main syllabus, unit number 1. That topic name or that unit name is spheres. First of all, I am going to define what is a sphere. Sphere is nothing but locus of a point which moves in a space in such a way that its distance is constant from a fixed point. Once again I am repeating. Sphere is nothing but locus of a point which moves in a space in such a way that its distance is constant or equal from fixed point. This is fixed point. In this case, this fixed point C is called as center of the sphere, and this constant distance is called as what? Radius of the sphere. Once again I am repeating. Sphere is locus of a point which moves in a space in such a way that its distance is equal or constant from a fixed point. In this case, this fixed point is called as, this fixed point C is called as center of the sphere, and this constant distance is called as what? Radius of the sphere. This is a definition of a sphere. It is similar to your circle definition in 2-dimensional space, right? Okay, now let us see theorem number 1 in this sphere. Theorem number 1. I am giving number for my convenience, but it is my order only. Prove that the equation of a sphere with center small a, small b, small c, with center a, b, c and radius r is x minus a whole square plus y minus b whole square plus z minus c whole square is equal to r square. Here each and every theorem is formula. In the problematic part, we have to take it as a formula. Prove that the equation of a sphere with center ABC and radius r is what? X minus a whole square plus y minus b whole square plus z minus c whole square equal to r square. That means this condition we have to use in the problematic area whenever you know center of the sphere as well as radius of the sphere. Before that, we must show this result. For that, first of all, I want to take a small diagram. This is our required sphere. We need to write the sphere equation only. Here the given center of that sphere, I am denoting that center with capital C, whose coordinates are what? Small a, small b, small c. And in the statement they given the radius of the sphere also. This is the radius of the sphere r. Right? Now we have to write this sphere equation. To write it, I want to take a point, a general point or arbitrary point on the sphere. I am taking the arbitrary point P, x comma y comma z on the sphere, right? Now let us find the distance from C to P. What is the distance from C to P according to our formalistic coordinate system first formula? It is what? Square root of x minus a whole square plus y minus b whole square plus z minus c whole square. This is distance from here to here, right? But once see in this diagram, observe cheyalama. Distance from C to P is same as the radius of the sphere or not? Here to here distance is same as here to here. But according to above diagram, CP is equal to R, means radius of the sphere. Just equate these two things. Now we have square root of x minus a whole square plus y minus b whole square plus z minus c whole square is equal to r. Now take square condition on both sides to remove this root. Squaring on both sides. Squaring on both sides will get x minus a whole square plus y minus b whole square plus z minus c whole square equal to r square. We got one mathematical expression like this now. After getting this now, basically here P is a point on the sphere now. If you can define locus of this point P now, you get sphere equation now. For that cause, here write down locus of P now. The locus of point P is, locus of P means what now? Here generally we take P as x comma y comma z now. No need to take separate locus here. If suppose you can take here P point as x1, y1, z1, in the locus of P replace x1, y1, z1 with x, y, z. But I taken directly P general point as what now? X comma y comma z. Then locus of P means what now? Directly you can write this expression now. It is what? X minus a whole square plus y minus b whole square plus z minus c whole square is equal to r. I told you, locus of this point P gives what now? Equation of the sphere or not. Now we say this is equation of sphere. This is equation of a sphere whenever you know center of the sphere and whenever you know radius of the sphere. If you know center and radius of the sphere, we can use this one as formula. This is about your first theorem. Next see theorem number 2 second theorem. Prove that the equation x square plus y square plus z square plus 2ux plus 2by plus 2wz plus d equal to 0 represents a sphere with center minus u minus v minus w and radius square root of u square plus v square plus w square minus d, where u square plus v square plus w square minus d greater than or equal to 0. This internal part of your root should be what now? Greater than or equal to 0. It never be less than 0. If it is less than 0, inside the root becomes negative. That's why we are making this condition. Apart from that, nothing importance for this condition. Once see the statement, especially see theorem number 2. Prove that the equation of this sphere. Prove that the equation of this sphere. Prove that the equation of this sphere is x square plus y square plus z square plus 2ux plus 2y plus 2wz plus d having center minus u minus v minus w and radius is this. Again here you can call this is general form of this sphere. If anywhere I want sphere equation immediately how to go through this equation only. What is that? X square plus y square plus z square plus 2ux plus 2y plus 2wz plus d equal to 0. This is general form of this sphere. According to this statement, what is the center of this sphere? Minus u minus v minus w is the center of that sphere. And what is radius of the sphere? Square root of u square plus v square plus w square. U square plus v square plus w square minus d. In this case, u square plus v square plus w square minus d should be what? Greater than or equal to 0. Now let us see proof of this. To prove this result, first of all, I want to take your given equation. What is given equation? It is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. This is our given equation. Now, if you want to show this is equation of the sphere, no, according to theorem number 1 or previous theorem, no, write this relation in terms of, write this relation as, express above relation as like this, x minus a whole square plus y minus b whole square plus z minus c whole square equal to r square. I mean, rewrite this relation as like this. Now, according to previous theorem, we say this is a sphere having center what now? A, B, C and radius R. I mean, here you get A is minus U, B is minus V and C is minus W1 and R becomes what now? Square root of R becomes what now? U square plus V square plus W square minus D inside the root now. If that can get now, this completes your above statement. That means our main aim is what now? You must express this equation like this. For that, I want to add one number on both sides, especially this number, adding u square plus v square plus w square minus d on both sides. We get this. Once do addition there. Yes, it is. First I am writing this total expression on left side. X square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d plus u square plus v square plus w square minus d is equal to u square plus v square plus w square minus d. Any problem is there? Just we add this relation on both sides. Here this plus d, this minus d gets cancelled, right? Next, write x combination terms with u. X and u combination terms one pair ma. Y and v combinations take as other combination ma. Z and w terms take as next combination. First I am writing x and u. And I mean above relation I am writing like this. X square plus 2ux plus u square. This is one combination ma. X square plus 2ux plus u square plus next one is y square plus 2vy plus v square is next combination. Next z square plus 2wz plus w square is third one. Left side completed once. All terms are over. Next keep right side as it is now. U square plus v square plus w square minus d1, right? Okay, once look this open bracket area, first open bracket area. This is in the form of a square plus 2ab plus b square. Is it a plus b whole square or not? I mean this you can write as x plus u whole square. Next this is what? Y plus v whole square. Next this is what? Z plus w whole square is equal to, for my convenience, I want to write this right side portion as square root of u square plus v square plus w square minus d whole square. Any problem? Basically, you can write p as root p whole square. Like that, this you can write as under root of this whole square. That I wrote on the right side, right? Again, come on left side. I am going to write x plus u as x minus of minus u. Any problem with that? I mean this is x minus of minus u whole square. Minus u to minus becomes plus, you get same thing, right? Next y plus v I am going to write as y minus of minus v and this is whole square, same thing, plus z minus of minus w, z minus of minus w whole square. Left side part completed. The right side keep as it is now, square root of u square plus v square plus w square minus d whole square. Once with this expression, this is in the form of x minus a whole square plus y minus b whole square plus z minus c whole square is equal to r square. X minus a whole square plus y minus b whole square plus z minus c whole square is equal to r square, right? Now according to previous theorem, what do you say now? This is a sphere with center what now? This is a sphere, clearly I am writing, which represents a sphere represents a sphere with center minus u minus v minus w minus u minus v minus w and radius r is what here? Square root of u square plus v square plus w square minus v. Is it complete square statement or not? We taken this equation, we proved that represents a sphere with center what? Minus u minus v minus w and radius is what? Square root of u square plus v square plus w square minus d whole square, right? But again, this one you have to use in the problematic part as formula. There we can use whenever they proceed one equation and if they want that sphere, basically that given equation is a sphere, whenever they want center and radius of that sphere, you can use this one as formula. If they given sphere equation and they want center and radius of the sphere, there you can use this one. First write given expression in this form, there minus u minus v minus w becomes what? Center of the sphere and radius is what? Square root of u square plus v square plus w square minus d, right? This is about your theorem number 2. But in this theorem, let us see a small two conditions. Here we taken u square plus v square plus w square minus d is greater than or equal to 0. Especially if suppose u square plus v square plus w square minus d is strictly greater than 0, then the sphere is called as real sphere. Then this sphere is called as what? Real sphere. Right? If suppose u square plus v square plus w square minus d is equal to 0, then the sphere is called as point sphere. Point sphere, or you can call it as zero radius sphere. Point sphere and zero radius sphere, one and the same. Right? This is about your theorem number 2.